control at 2 hours 49 minutes. We're standing by now to acquire radio contact with Apollo 17 through Hawaii. During this Hawaiian pass, we're getting another good look at spacecraft and launch vehicle systems. The last look we had through Canorvin, everything looked very good. Flight Director Gene Kranz going over the status with his flight controllers. Observed that there appeared to be no problems that would interfere with TLI, and we'd expect to have a normal translunar injection about 23 minutes from now as Apollo 17 completes its stateside pass and moves out over the Atlantic Ocean at the start of its third revolution.
Houston, this is Apollo 17. Go ahead.
Hey, Ron, you're sounding great. Good voice here.
Oh, yeah, we got things all set up here, and we're kind of standing by for a logic check whenever you guys can give us a go.
Roger. As soon as we get some TM in here, we'll give you a go.
Okay.
Houston, we're ready for the logic check.
Okay, Bob. Okay, what? Okay, 6 arm breakers are closed.
Roger.
Okay, and logic 1 is on, mark it. And logic 2 is on, mark it.
17, you're go for pyro arm.
Thank you. Understand. Go for pyro arm. Bob, in case you're interested, all through the night side pass here, there's quite a strong, well, stronger than I would have ever expected, horizon glow off to the north. I suspect that, I think Gene said a while ago, it's around on his side also.
Roger. Guys, I've got the word you wanted to hear. You are go for TLI. You're go for the moon.
Okay, Robin, understand. America and Challenger with the S4B are go for TLI.
That's affirmative.
You're a sweet talker.
We try to please here, Gene.
Yeah, somehow, Bob, I knew you were going to say that. We were go, and that you try to please.
We've been working together too long, eh?
Not long enough yet.
17 Houston, you're about 1 minute from LOS, and we'll pick you up at Goldstone at about 3 hours and 00 minutes, and that's only a couple minutes prior to time base 6 start.
Okay, Bob, we'll be with you.
Roger.
Bob, that glow is actually above the horizon, just in case you're curious. I can see stars below the top of the glow, down closer to the Earth.
Roger, Jack. Houston, we're with you again, and you're looking good.
Okay, mighty fine, Bob. And Bob, we've got the pyros armed now.
Roger. And you could expect some different Omni calls as we go LOS and AOS again.
Okay. Always expect that, Bob.
Roger.
Is on time.
Roger. Data shows time base 6 right on time, Jane.
Okay.
We'd like Omni Delta, please.
Okay, you've got it.
Roger.
I'll just switch, Bob. I won't give you a call.
Roger.
Subflight was on time.
Roger, Jane.
This is Apollo Control at 3 hours 4 minutes. We're now some 8 minutes away from ignition. Everything looking good for the translunar injection maneuver. The combined S4B, the Saturn third stage, and the spacecraft with an orbital weight of 308,298 pounds at the start of this maneuver.
Time check, Bob. down there. We almost forgot you're there.
Roger. Don't want to forget me. We're just watching everything. We can't find anything wrong, so we're just trying to keep quieter.
Okay, Bob. We're watching the S4B tanks pressurized.
Roger.
Gotta look for the good things rather than the bad.
Well, that's good when we don't find anything wrong.
Can't agree more.
The chill down is in progress, and the tank pressures are looking good.
Okay, Bob. Looking good here.
Houston, you are go at 3 minutes prior to ignition. You're looking good, and we're gonna have a riot coverage all the way through the burn until in session.
Roger, understand, Bob. 5710, RDL operate.
And we're coming up now on 2 minutes until ignition. This burn again will be a 5-minute, 51-second maneuver. The S4B engine delivering about 225,000 pounds of thrust, and it'll be increasing the spacecraft velocity from the current speed of about 25,000 feet per second up to around 35,585 feet per second.
Roger, we confirm it.
Zipline on at 36.
Roger.
and booster reports the ullage engines are on. This is to settle the propellants in the S4B prior to ignition. We're 53 seconds now from ignition.
You're looking great on a final status check here, and you're go for TLI.
20 seconds now to ignition, and we're maintaining communications with the spacecraft through one of the Orion Apollo range instrumented aircraft.
Roger.
10 seconds. And very faintly, we copy the crew reporting S4B ignition. That's confirmed by the telemetry. Booster reports the thrust looks good on the S4B.
17 Houston, you're looking good, and the thrust is go.
Bob, you're doing it fast, but we're go on board at 20 seconds.
Roger.
And telemetry data from the Saturn instrument unit shows the velocity increasing, up now to 26,000 feet per second, beginning to climb ever more rapidly. This burn was initiated at an altitude of about 97 nautical miles above Earth. When finished, the spacecraft will be at about 150 miles above Earth and on its way to the moon, some 213,000 nautical miles away.
Roger, Gene. We can barely hear you through the Orion, but you're go.
Very weak voice communications, and Booster says the data is now static, but at last look, everything looked normal.
Houston, we can confirm PU shift, and you are go.
And that was Capcom Robert Overmeyer confirming to the crew that our data showed the Saturn shifting its propellant utilization for most efficient utilization of the propellants.
Then 2:30 in the blind, we're still go.
Roger, 17, you're go. Looking great.
Okay, Bob, got that. Understand we're go from the ground, and it's a good ride, although it's rumbling around a little bit.
Okay.
Coming up now 3 minutes into the burn, and the velocity approaching 30,000 feet per second.
3 minutes, and we are go.
Roger, Gene.
Bob, we're going to TLI right through sunrise.
Roger, understand.
Gene Cernan reporting the TLI burn has taken them out of darkness and into sunrise now. And we're showing a velocity of 30,463 feet per second.
Roger, 17.
Apollo 17 now about 107 nautical miles above Earth and continuing to climb ever more rapidly. 4 minutes 30 seconds now, and everything continuing to look good. Apollo 17 at a velocity of 32,000 feet per second.
At 4:30, you're still unreadable.
Roger, how do you read me? You are go, by the way.
Okay, we got you that time. Understand we're going to ground. We're still go here, and we're TLI and right through at sunrise.
Understand.
Five minutes now, less than 1 minute to go. And booster engineer reports we're very close to the nominal predicted shutdown time.
Houston, your burn time is nominal.
Roger, understand burn time nominal.
Shutdown now in about 21 seconds. We're showing a velocity of 33,000 feet per second. Altitude now approaching 150 miles.
Cut off at 5-2. You read the disky?
We don't have the disky. You have to read it to us, Ron.
Okay, VI is, I got a 00 and a 00 on a 995. VI is 35573. Is a +9. And Bob, the EMS is minus. EMS is minus 19.4. Minus 19.4.
Roger, we copy that.
And it was an auto cutoff. Auto cutoff on time.
Understand, a guided cutoff on time. Looking great.
And I'm watching the tank pressures are venting. The tanks are venting.
Understand, tanks are venting.
And we're still getting communications through the Apollo range instrumented aircraft. We'll be picking up through Ascension shortly, at which time we'd expect the communications to improve, the noise to drop off. From Gene Cernan's report, also from the reports from Ron Evans, it appeared that translunar injection was extremely close to nominal. The crew read a cutoff time of 5 minutes 52 seconds. The pre-maneuver prediction was 5 minutes 51 seconds. And the cutoff velocity appeared to be very, very close to the planned normal. Booster engineer Frank Van Rensselaer reports the booster cutoff appeared to be exactly normal. And booster engineer now predicting that the maneuver to separation attitude will begin at about 3 hours, 33 minutes, 27 seconds.
Houston, how do you read?
17 Houston, we'd like Omni Delta.
Okay, I picked it up a little bit. How do you read now?
Read you loud and clear.
Okay, I hope you got all that. It was a beautiful burn right through sunrise. Did you get the numbers?
Yeah, we copied your VI and your EMS numbers, and we've got a number for you. The maneuver start time will be at 3 plus 33 plus 27.
Okay, we got you maneuver at 33327.
That's affirmative, Jack.
You guys didn't tell us we couldn't see anything going through the sunrise.
Roger. Houston, we're making plans here for a spacecraft SEP time of 3 plus 43.
3 plus 43, roger.
Houston, we're copying cabin press of 5.9er this time.
Roger, we just got it, Bob.
Okay.
Thank you.
This is Apollo Control at 3 hours 30 minutes. The flight dynamics officer has just reported that initial tracking following the translunar injection burn shows the spacecraft to be on a very nominal trajectory and a relatively small mid-course correction indicated at this time. The pre-burn prediction on that first mid-course correction was around 5 feet per second, and we expect that that will be updated as we get additional tracking following the burn. In about 3 minutes, the spacecraft should, the launch vehicle, should be begin maneuvering to the proper attitude for separation, and we're predicting separation to occur at about 3 hours 43 minutes, or about 13 minutes from now.
Frame 6.5 for the LNV's mag, November.
About 10 seconds now until the Saturn third stage begins maneuvering into the proper separation attitude. And booster engineer reports from telemetry data that the booster has begun maneuvering into the proper attitude for spacecraft separation.
Okay, we are maneuvering, Houston.
Roger, we're watching it.
And we got a few very bright particles or fragments or something that go drifting by as we maneuver.
Roger, understand.
Yeah, there's a whole bunch of big ones out my window down there. Just bright. Looks like the 4th of July out Ron's window. Yeah, now you can see some of them in shape. They're very jagged, angular fragments tumbling.
Roger, they look like fluid of some sort?
Not to me. They look like pieces of something.
Roger.
They're very bright.
Jack, we'd like Omni Charlie.
Bob, for the most part, these fragments are not are tumbling at a very slow rate. I've tried a couple pictures of them at different settings. You may get an idea of what at least the patterns look like.
Roger, I got you. We're all ears on these fragments if you think you can figure out what they might be.
Well, you know, I don't know. There are a number of possibilities. If you had some kind of a... I got the impression maybe they were curved a little bit as if they might be off the side of the S4B. That's a wild guess.
Okay, RCS logic is...
ice chunks, possibly. Maybe there's paint coming off of it.
Right, I noticed on one trip up the elevator last week, one of the flags, I thought it was in the S2, but it might be on the S4, looked like it was peeling. Maybe that's what you got. And the S4B maneuver is complete.
1 minute.
Okay, we'll set 2 o'clock.
Okay, and with the maneuver complete, the fragment field is essentially static, except for very slight tumbling within the fragment.
Roger, copy that.
Every once in a while, a fragment of considerably higher velocity than the others goes across my window, but that's very rare.
Roger.
Hey, that's that field of view I saw on my window deck. You see it now? Yeah.
And Bob, at least there's no apparent relative motion between fragments.
Roger, understand.
I'll take 2 pictures about a minute apart if I can, and it'll be frame 70.
Okay, frame 70.
And Bob, Gino, my impression is that they are flat, flake-like particles, some maybe 6 inches across, and although there's no relative motion between the two, most of them seem to be twinkling, and I think for the most part they're all moving away from us.
Roger, Gene, thank you.
Okay, we've got 0, 180, and 0 on the old thumb wheels.
Roger.
Okay, Trans Control is armed. Controller number 2 is armed. Okay, sex logic is closed, sex armor closed, logic power is on.
Houston, you have a go for T&D.
Okay, a go for T&D.
Okay, we'll arm the pyros. And we'll hit the GDC line. Yeah, maneuvers complete. Okay, 0, 180 and 0 on the GDC. No, it's just in a dip in. It's kind of dipping. Okay, that'll be a normal. S4B, okay. Okay, switches are all set. Okay, let's start the DET. Tickety tick tick.
Okay, Houston, we're running at 5930.
Roger.
Okay. Okay, that's the launch vehicle set. Push button. MC and auto. Next.
Separation, Houston.
Hey, check the, whoever it is. Okay. And check the ones off. Okay, I'm going to start the, my God, look at the junk. Okay, there's 15 seconds. Picture up. Okay, we'll proceed on the, okay, we've already proceeded. Okay, we checked her out.
Houston, we're right in the middle of a snowstorm.
Roger, and we'd
Okay,
like
here
Omni Delta.
Hey, look at that bird. That's going to be bright as all get out.
And there goes one of the slop panels.
Yeah. We're not there yet. Long ways to go yet. It's on the other side of the earth, if the simulator's any good.
Apollo 17 now in the process of turning around after having separated, blown the pyrotechnic charges that separates the spacecraft from the Saturn III stage.
Roger, bet you never saw the slaw panels on the simulator.
No, but we've got the booster, and is she pretty? Challenger's just sitting in her nest.
Roger. We like Omni Bravo now, Jack.
Okay, plus exit, let's see, nice, or can't see this, nice, 7 Okay, can't see my COAS.
And Houston, some of the particles going by the window
Yeah,
were
you changing that?
fairly obviously to be paint.
Okay, we'll buy that.
Okay. There it is. Okay, you changed it up. Got that one right too. Okay, Houston, you want the high gain?
Roger, we're standing by for it, and the angles as published on L3-3 should be good.
Okay. Okay, it's flying pretty good. Okay, we're in REAC here. Yep. Houston, how do you read? We don't have a very good lock on here in REAC.
Roger, Jack, we're reading you pretty good voice.
Okay, it looks like it's improving. It dropped off, signal sync dropped off, and now it's picking up again.
Roger. We're getting good signal now, Jack. Jack, the high gain is looking good.
I'm guessing, I don't know, about 100. That's great news. Seemed to slew very smoothly, so looks all right.
Roger, Jack.
And one right too.
Can't tell you too much, Bob, from the center seat other than Captain America is very intent on getting Challenger at the moment.
Roger, I can believe that.
Yeah, I'm coming in a little slow, but we got plenty of time.
Ron Evans now at the controls of America, moving in for the docking with the Lunar Module Challenger.
And while we're moving in here, I can see a few chunks of that plating material, possibly paint, down in the slaw, sort of bouncing around between the S4B and the limb.
Roger.
But so far, limb looks very clean. Can't see anything abnormal from this view yet.
Okay.
Isn't it though? That thing is really stable out there. see it at all, Chief.
Got one little chunk coming out, just came out of the slot and spinning along a long axis and looks very stable.
Roger.
Every once in a while a small particle flies off of it though.
How big a chunk you talking about, Jack?
Say again?
How big a item are you talking about?
Oh, I referenced to the thrusters, about the same diameter as the thruster on the limb.
Roger.
That's how long it was, and about a fifth that thick, or that wide.
Roger.
And I don't think it's more than a quarter of an inch, maybe even less thick. That same particle, Bob came by, and as it was spinning, it was throwing off pieces of itself radially out.
Roger, we copy.
There's small ones come floating by, they look like flakes. And I think I caught 3 of the 4 slop panels going as we were maneuvering. I've got one out the hatch window now. It's quite a ways out.
Roger.
Tumbling in all 3 axes. And I saw the 4th one out my side, so we saw them all. Area around the 2 spacecraft is cleaned up pretty well by now. There are just a few fragments moving around. She's coming in.
The crew of Apollo 17 describing what would appear to be paint or possibly ice flaking off the Saturn third stage. But somewhat puzzling at this point is just exactly what the flakes or particles that they're describing might be. And Apollo 17 in the process of docking with the lunar module, preparatory to extracting the LEM from the Saturn third stage. This occurring at some 5,300 nautical miles from Earth. And we're watching the spacecraft velocity drop off rapidly as that altitude increases rapidly. The velocity, which at the translunar injection cutoff was around 35,000 feet per second, down now to about 22,000.
Roger, Jack. Can you see down on that quad? Is that how you're looking at it?
Yeah, I'm looking right at it. And I got a good view of the mesa top anyway. It's pretty well covered, but looks all right also.
Roger.
All the antennas look good. thruster quads all look great. I could see all four of them a minute ago. Okay, about 10 feet there, Gene. Stand by for on the barber pole. Okay. All right, good shape. About now. Capture, Houston.
Roger, we copy.
Okay, we're free. Rates look pretty good. Let's lock it together. Ready. She's lined up, not bad. Okay. Prime 1. Mark it, stand by. There she comes. Good talk. Hi, guys. Okay, Houston, ripple fire, but we still have number 8 barber pole.
Roger, we copy.
We have a master. Got a master alarm.
Roger.
We got the most of the latches, but A is barber pole and B is gray. Okay, check both circuit breakers. Okay. We had one clear fire, maybe one or two latches, and then a ripple fire of the rest.
Roger.
And by the way, I had a good view into the AOT, and I can still look in there, and it's very clean.
Roger. Ron and Jane, we saw your master alarm. Did you have anything on the matrix light up?
No, not a thing. I looked.
Roger. That would appear to be a repeat of the master alarm that has been reported several times previously by the crew. They get the alarm light and tone, but when they look for the exact indication, or the precise indication of what's wrong, it's not there, indicating some sort of a spurious response by the master alarm to a problem that doesn't exist.
Okay, Bob, we're going to go ahead and take a look at that docking malfunction before we press on through further and check this barber pole out.
Roger, we're working some words up here. We'll be back within a second on that, Jane.
Okay, we're down at a checklist through the power breakers open.
Understand.
in case we didn't tell you, it's talkback A that's observable.
Understand, we have it. Say, 17, we don't think it's a problem. We'll find out what it is when we get in. We think we should just press right on with the flight plan checklist and keep going.
Okay, we concur with that. Okay, we'll press on, Bob.
Okay, Bob, we just got a master alarm when I went to the retract prime from 1 to off.
Alright, we copy that. Looks like panel 2 is Jinx up there, huh?
Okay, O2 heater number 3 went to auto.
Do we copy that?
Okay, Bob, we're reading a delta P of greater than 4, and I'm going to open the pressure equalization valve now.
Roger, 17, we copy that.
Okay, the delta P's coming down, Bob.
Roger. Gene, while you're watching that, I just thought you'd be interested. We talked to some of our friends down at the Cape who watched the launch, and they said you were glow all the way until you faded into, you couldn't tell you from a star. They saw staging, and they could just see you as a star way off in the distance until you faded out. Not a cloud in the way at all.
Beautiful. Okay, we're at 2, and we're monitoring it for 3 minutes.
Okay.
And Houston, while we're checking the integrity here, mag alpha alpha, there's about 50%.
Mag alpha alpha, 50%, Roger.
This is Apollo Control at 4 hours 12 minutes. The crew aboard Apollo 17 at this time pressing ahead with their preparations for separating the lunar module and command module, now docked together from the Saturn third stage. You heard some conversation earlier about an indication that all of the docking latches had not locked up. There are 12 of these latches in the docking mechanism, 6 of which are instrumented. And of the 6 that are instrumented, there was an indication that one of those may not have latched. However, we're confident that more than enough latches have locked up to assure a good solid dock, and for that reason the crew is pressing ahead with their preparations for separation.
Delta P change is less than 0.1.
3 minutes and less than 0.1.
We are pressing on.
Roger, press.
And that report from Gene Cernan indicating that they have a good seal at the docking interface. Once the hatch is removed between the two vehicles, the crew will get a good look at all of those docking latches, and we'll be able to tell how many, if any of them, didn't latch up. We're pushing ahead now for extracting the lunar module, separating from the Saturn third stage at ground elapsed time of 4 hours 39 minutes.
Okay, what, cabins at 4-8 now, repress is about empty. Okay. No, not yet, it's still getting a little bit. The repress package valve's kind of noisy. Yeah, it's all the repress. We'll turn that off.
Okay, Houston, the repress package is empty now, and we're down to a delta P of 0.2. Do we copy that? And 17, just be advised, you're going to have an S4B non-propulsive vent start at 4:18:27. You get about 3 minutes on that.
Okay, thank you. Yeah, I'll get him.
Okay, Bob, we seem to be holding delta P at about 0.2. I suspect that's probably 0. Roger, we copy that.
And the cabin pressure's about 4.5. You want us to wait till 5 psi for the emergency cabin pressure selection?
Negative on that. Let's go ahead and just press on.
Okay. This should be both. Okay. Emergency regs are working. Coming down though, Jesus. Wait till it gets down a little ways.
It's really glowing.
Your non-propulsive vent gives quite a glow.
Roger, Jack.
It looks like a rainbow. Darkly. Okay, repress package to fill. Take the surge tank down a little bit. Stop that at what, 400? $500 on the surge. No, they ought to be closed off by now, I think. Yeah.
17 Houston.
Go ahead.
Roger. Be advised you don't have to wait till 5 psi cabin to go ahead and open the hatch.
Okay, we're not Bob. We're pressing on with it now.
Roger.
Okay, it looks like we're going to maintain about 400 on the surge. Okay.
Okay, Houston, the hatch is coming out.
Roger.
I don't know what you're going to do with it. Put it up here on the couch. There we go. Yeah, it's a lot lighter than it used to be.
There's going to be a lot of happy people down there, Bob. I haven't checked them all, but visually they're all locked.
Understand, Jane, all of them are locked.
Let me give them a good check.
Hey, you better check them because we got a barber pole on that one.
Okay, you're the one that can go over.
What is the position of it? 7. Seven and 9?
Okay, Bob, maybe we aren't all going to be so happy.
Go ahead.
7. Okay, 7, 9, and 10. The handle is flush. The bungee is vertical. But the handle is not locked down, and the red button is showing, and I can pull each one of them back slowly. I haven't done anything with them. That's 7, 9, and 10.
Roger, we copy that. The handles are flush, the bungees are vertical, but the handle is not locked down, and the red button is showing on 7, 9, and 10.
That's for... Okay, Bob. Bob, I just pushed the handle on 10 home a little bit, and it did lock, and the red button is flush. So that leaves me 9 and 7.
Roger, understand. Jano, go ahead and try the handle on 9 and 7, and if that doesn't work, cock them and refire them, starting with 9, please.
Okay, the handle, it doesn't work. I'll have to recock them.
Okay.
With your triple, with your cock it twice, and it took 2 clocks to make it go. Okay.
Okay, 9 cocked twice and tripped. It is over center and locked.
Roger, how about the barber pole now?
Okay, wait a minute. I got target probe main A circuit breakers in, going to retract, and it's gray.
Okay.
That did it.
Roger. And
Okay, Bob, cocked 7 twice and tripped it, and it's over center and locked.
Roger.
I think that takes care of them all.
Good show.
Target probe circuit breakers are out, and extend retract is off. Because it belongs on the probe. If it's painted yellow, it belongs on the probe.
Okay, Bob, the umbilicals are connected.
Roger.
Houston, 7 Delta on the test meter is now reading 1.0. It jumped up to 2.6 and is now back to 1.0.
Roger, we copy. That's good.
This is Apollo Control at 4 hours 30 minutes. About 9 minutes from now, the crew will be firing the pyrotechnic charges that separate the lunar module docked to the command module from the Saturn third stage. And springs will push the LEM CSM back away from the launch vehicle at a rate of about 1 foot per second. Then at ground elapsed time of 4 hours 52 minutes, the launch vehicle will yaw to the proper attitude for an evasive maneuver of about 10 feet per second to be performed at a ground elapsed time of about 5 hours 3 minutes. This will increase the separation distance to assure no chance of recontact between the booster and the spacecraft en route to the moon. On removing the hatch between the LEM and the CSM, allowing the crew to get a look inside the docking tunnel, they found that 3 of the 12 latches had not locked up, but on manually recocking them and activating them, they latched up properly, which indicates that there's nothing physically wrong with the system. And we would expect that the next time the 2 vehicles come together to dock that the latches will function properly.
Pretty good damn savage.
Okay, Bob, the hatch is back in.
Roger, Dean. Houston.
Go ahead, Houston.
Roger, we got some new angles here for you.
Stand by a minute. Let me find a place to copy them. What kind of angles are they, Bob?
They're your now 22 attitude maneuver for apse burn out of the hatch window. The middle of page L3-5.
Oh, okay.
Instead of 270, we want 274.
Wait one, we're not quite with you.
Okay.
Okay, I think I marked you 3-7, go.
It's on 3-5, Jack, in the middle of the page there, those Mound 22s.
Okay, I'll take it back, 3-5, middle of the page.
Okay, you notice there's three angles there. 270, make that 274.
Okay, that's the only change?
And the next one, the 129.8, change that to 164. And the 4.3 on the yaw, change that to 0. It's close enough. 0 on the yaw.
Okay, we got them. 274-164-00.
Roger, and the high gain angles that you got in the flight plan are close enough and should do it.
Very good.
Telemetry data now shows the crew loading the information into the spacecraft digital autopilot in preparation for separation from the Saturn third stage. That should be occurring in the next minute or so.
we're 6 frames a second. Okay, what it got a range one of this thing? Yeah, I'll leave it at 10 feet and about an F8. Okay, Molo 1, that's it. Because I had that one, the 0180.
Okay, Bob, we're lining our GDC, and the next thing we'll pick up will be the sharp circuit breakers, and we'll give you a call on the logic.
Roger, Gene.
Okay, Bob, while we're waiting, is the balance on the
What you mean?
H2 and O2 flow in fuel cell 3, well, actually in all 3 fuel cells, look pretty good to you?
Jack, the flows look just right for the currents.
Okay, used to seeing them more or less lined up, and I hadn't calculated any farther than that.
Roger.
O2 seems a little higher in H2, relatively speaking.
Okay, that's pretty close. Verify, 6 arm breakers are closed.
Okay, Houston, we're ready to come up with the logic.
Okay, Houston, logic 1 is coming on now, and logic 2.
Roger.
And Houston, just to keep track of it, EMS no bias check that time was, went from 100 to 100.7 in 100 seconds.
17, we'd like to just verify on that top line, S4B/LEM, SEP circuit breakers, both of them are closed.
Okay, we'll verify them again. We double checked them.
Okay, we just didn't hear your call. We want to make sure that. Didn't want to miss anything here.
Okay, they are verified, closed, and Jack just checked them again.
Okay, you are go for pyro arm and go for extraction.
Okay, go for firearm, go for pyro extraction, or limb extraction. Okay, firearm.
Okay, we'll arm the old pyros. There's pyro A, pyro B. TVC servo power, AC1. Trans control power's on. Okay, road controllers are armed. Okay, I'll wait just a little bit on that. EMS and all. Tell Adina. Mr. Normal. Switch right there. Yep.
Okay, my mark, S4B LEMSEP will come on.
Okay, now I'll back it off to the... Okay.
Okay, on my mark, S4B LEMSEP. 3, 2, 1, mark it. Okay, we got it.
Oh, man, did we? There she comes. Yeah, Lem came with us. Okay, where's the MC on it? No, we got 6/10, all right. Okay, what do you do? Safety barrels. Okay, logic's off. Flex arm, breakers are open.
This is Apollo Control. America and Challenger are on their own. LEM ejection occurred at 4 hours 45 minutes ground elapsed time at an altitude of 13,000 nautical miles from Earth.
Well, we ought to go to the maneuver pretty quick. Otherwise, the S4B is so far away, I can't see it. Okay, ready to maneuver? Okay, CMC and auto cage. There we go. That jolt wasn't as bad as the original set. Yeah. Came right out though.
Mapping camera and pan camera are off.
Okay. Power's on. Hey, Jack, hand me the Hasselblad. I think we're pulling in the right direction. Yeah, the moon is there. The Earth is, that's the Earth. Server power's off, yeah. The Earth just fills up window 5. Okay, F-infinity, about a 250th. F11. F11. What do you have, a 0 in there? Hey, I lost my watch. Turn the AC on. Yeah, AC is on. Ooh, what a beauty. What a beauty. Yeah, the Earth. I can't see the S4B, it's gone. Look at that. Yeah, Madagascar and Africa. Let's see. Got to be. Yeah, as soon as I find this, we'll be on. Hey, there's Antarctica. It's all full of snow. Okay, you want to look? Yeah. Is she? Yeah. Oh, there it goes. There. Looks kind of empty down here without the limit.
Okay, Bob, we're looking right up the dome of the S4B.
Roger, we copy that. We're standing by for your go for our yaw maneuver.
We can give a go for the yaw, can it? We can see it now.
Yeah, we can see it. You got to go for the yaw.
Roger, thank you, 17.
Looks like she came out of there clean as a whistle.
17 Houston, the yaw maneuver will be starting in about 4 plus 5, 2, a little less than 2 minutes from now.
Okay.
Sounds like you're taking pictures of that old dome out there, huh?
Oh. We're at the empty. Okay. Hey, there it goes. Look at the amplifier in the thing.
Yep, we can see it fire now.
Roger, 17, the yaw maneuver started.
The Saturn third stage now, maneuvering into attitude for the apse evasive maneuver, 10 foot per second burn using the auxiliary propulsion system that'll assure.
The flare for the dramatic, but it certainly did its job for us.
Roger, Jack. Preliminary data will indicate you're about as nominal as you can be.
That's the way we'd like to keep it, Bob.
You better believe it.
Okay, she's, as we're looking at it, she's pitching up. She was looking right at us. We were looking right at the dome, and now she's pitching up. The shroud around the IU seems to be totally intact. It looked like a super clean separation. I can't really see where there's any paint or anything externally chipped off the booster from here. We're beginning to pick up the bell. It's really a shame you don't have this whole thing on TV. It's really quite a sight.
Roger, we concur with that.
The mylar, or the gold coating on the inside of the shroud that's now visible is also intact. It looks like you could use it again if you could get it back.
Well, it's got a job to do when it hits the moon yet.
Bob. We're almost looking at it broadside now.
Roger.
Okay, she's spitting a little. Looks like the yaw maneuver may be complete. We got a full view of the entire J2 from here. And no kidding, Bob, the whole bird, the shroud at the top by the IU, the separation plane down by the S2, from here all looks as clean as a whistle all the way.
Roger, Gene, if you're happy, we'd like a go from you for the evasive burn.
Okay, you're going to burn on the booster's plus x-axis, is that right?
That's affirmative.
Let us get a picture or two here yet, and we'll give you a go.
And Gene, it'll be about 7 minutes of the evasive burn, 5 plus 03.
Okay, you have a go. And for your reference, at frame 105, I started a few 250 millimeter pictures of the S4B.
Roger, Jack.
And Bob, the entire sky, as far as I can make it out through the hatch window, is completely filled with our twinkling flakes.
Roger, we copy that.
I saw a couple particles go by the window a while back, and it looked a little bit like insulation in that particular case. Styrofoam insulation, but in flat flakes.
Roger that.
That was right after we separated from the S4B.
Roger.
CSM 7. CSM 7, Bob.
Roger, understand.
And Bob, I know we're not the first to discover this, but we'd like to confirm from the crew of America that the world is round.
Roger, that's a good data point. Have you gotten a good look at any of that weather down there on the Antarctic?
Saw out Ron's window number 1. Maybe he can tell you a little bit about it.
You know, it's real funny there in Antarctica. You can see the snow, but there isn't any weather at all on it. All the weather's around it in the water.
Raj.
Oh,
17 Houston.
go ahead.
Looks like you've got a super conservative CMP up there. We've run out some numbers. Looks like you use about 40 pounds of RCS on the T&D, and you've used about a total of 42 pounds RCS total, so we're hanging right in there. Beautiful.
Very fine. Glad to hear that. Good. Velvet touch.
Oh, a little bit too much, but that's not bad.
We'll be glad to leave all that extra, I hope, in the service module when we get home.
In the Volkswagen pouch down there. Oh, geez, let's know.
17 Houston, it's about 30 seconds from the evasive maneuver burn.
Okay.
Here, Jay. Can you see him good? Check the settings there. I took an F-22 smoke.
There it goes, Bob. There it goes, finally.
Roger.
This is Apollo Control at 5 hours, 5 minutes.
The burn is complete, and the LOX dump will be at 5 plus 24 plus 20.
Okay, 5 plus 24 plus 20.
Roger.
He's going to be gone, I think, before we can see him.
And Bob, you can tell Frank to forget returning that phone call I made to him a couple days ago.
Raj, understand.
All my questions are answered.
Think you've had enough booster briefings, huh?
Yep, I figured this was probably the best one of all.
Frank said he'd guarantee all his S4Bs to be just as good as this one.
Okay, that's fair enough. CNES 2 didn't put on a bad show either.
That's right.
Houston magazine, November's on about 123 right now.
Okay, we're on magazine November. November is on 123.
And Bob, we're on page 3-9 of the flight plan now. We'll check the Lamcium Delta P, get the cabin fan filter in. We'll go over the systems checklist, get the primary evap and a few odds and ends, and start off on our PGAs. How's that sound?
Sounds like a winner, Gene.
Okay. I guess you saw that one, Houston. That had no caution or warning with it.
Right, is that a master alarm?
Yes, sir.
How about the LEB?
Gene's got... Say again? You caught me. Forgot to look. Keep after us. We'll get you
you that data point.
Roger, Jack.
Gene's got his hands all over panel 2, which probably is what caused it.
Jack, we think that might have been a real one due to the accumulator cycle with the O2 makeup flow going on there. It held the O2 flow higher than for greater than the 16 seconds.
Well, that's certainly a possibility. We didn't notice it, looked up right at the time, but it, sure that was the right time?
Well, he counts watching it here, and it's he feels it is.
Gee, I can't argue with him. Okay, Houston, ready to deactivate the primary evaporator if you concur.
Roger, Jack, we concur.
Okay, Bob, VHF simplex alpha's off.
Roger.
And we're gradually moving into getting out of the suits.
Yeah, I bet you're looking forward to that.
Well, I tell you, it's a different world without that old 1G on you. The old suit's a little bit friendlier.
honest, Bob, we've come to the end of the launch checklist.
That's affirmative, and we've put ours away for posterity. We also started with our TLI 0 data that we worked so hard to generate.
Well, I'm just happy didn't use it. That view of the Earth for Rev there was something I was looking forward to and was not disappointed.
That's great, Jack.
Bob, you've got a pretty good sized storm over the the northwestern coast of India, where it starts to wrap up and around to the west. It's rounded out on the horizon, so I can't make out exactly where it is too well.
Oh, roger. Could we get a readout on the limb CM Delta P?
Plus 0.4.
Roger, we copy that.
Bob, Antarctica is what I would call effectively just a solid white cap down on the South Pole. There's definite contact between the continent and the water, but as Ron said, most of the clouds seem to be very artistic, very picturesque, some in clockwise rotating fashions, but appear to be very thin, where you can, for the most part, tend to see through those clouds to the blue water below. But the continent itself is the same color as the clouds, but of course more dense and a striking difference than any of the other white background around, because you can definitely see that contact with the water and with the clouds over the water.
Right, I understand. It's going to be a comm switch over to Madrid here shortly. We may break lock in a few minutes here, or a few seconds really. And you might watch your accumulator is going to cycle in about 20 seconds here and see what happens on the master alarm. Houston, how do you read through Madrid?
You're loud and clear, Bob, and could you give us our distance from the Earth, please?
Roger, I'm looking up at the board. I'd guess about 19,000 miles, but let me get it exact.
Just approximate's good enough.
18,100, Fido says.
Okay, and I suppose we're seeing as 100% full Earth as we'll ever see, certainly as I've ever seen. It appears to be, it may be a little bit of a terminator way out to the to the east, out beyond Australia and beyond India, but beyond that it's about 99% pure. Bob, it's these kind of views that stick with you forever.
Roger, Gene.
We've got I guess probably the continent of Africa dominates the world right now. It's covering the upper third, upper and western third of the world. We can see the Sinai. We can see up into the Mediterranean. We can see across the Mediterranean, although we can't quite make out the countries up there. We can see across into India. I can catch a glimpse of Australia out on the far horizon. Got Zanzibar in the southern tip of Africa, the Cape down there just almost directly below us. And I don't know exactly how big Antarctica is, but I guess we can certainly see more than 50% of it. And the rest of it is all ocean. The Indian Ocean out into the Pacific Ocean and back into the Atlantic Ocean. And for the most part, relatively clear clouds, except in the Antarctica region. And up towards Europe, which is on the horizon, across the Mediterranean, it looks like there might be some clouds back up in that way. I could I can make out the entire coast of Africa from Mediterranean around to the west, coming back to the south, back where it takes its big dip to the east, back around the Cape, back around up through the Suez Canal, almost perfectly.
Roger, we understand.
And there's one batch of clouds in northern Africa, just a small batch. It looks like it may be up near the, well, no, it's not near the mouth of the Nile. It's quite a bit west of that, as a matter of fact. I can see the mouth of the Nile. I can see it running straight down towards us as it parallels the Suez, and then sort of fades out into the central darker brown or darker green portions of Africa.
Roger, Gene. Sure be nice to have that on TV, wouldn't it?
Oh, I'd love to give it to you any way I could. You know, and there's no strings holding it up either. It's out there all by itself.
Roger. I just was going through the 17 status report on CSM systems, and boy, everything is absolutely nominal with the exception of those glitching master alarms that we're trying to still track down, but every other system is just nominal. Everything's great.
Okay, sounds good. That's the way they build it for us.
Gene, looking at our platboard, you're directly over the southern tip of Africa, or just slightly out in the Indian Ocean there, according to our platboard, which isn't exactly accurate all the time. But shortly you're going to start going backwards on the Earth here and head back across the Atlantic. That ought to be some sort of a first. You cross the Atlantic twice, going from west to east, and then now you're going to cross it going from east to west here shortly. All in a very short span of time.
I guess that does sound like a first.
This is Apollo Control at 5 hours 30 minutes ground elapsed time. The white team of flight controllers headed by Gene Kranz is in the process now of handing over to the team headed by Flight Director Pete Frank. After 12 hours, the team came on about 3 hours prior to the scheduled launch time of 8:53 p.m. Central Standard Time. Of course, launch occurred 2 hours 40 minutes late at a ground elapsed time of at a Central Standard Time rather of 11:33 p.m. As a result of the late launch time, the translunar injection events up through translunar injection also slipped 2 hours and 40 minutes. We would expect that the translunar injection, which is targeted to make up the difference, will get us back on the nominal flight plan time by the time the spacecraft arrives at the moon. In other words, arrival time at the moon would be at the same Central Standard Time as called for in the flight plan at about 1:49 p.m. Central Standard Time, December 10th. But the ground elapsed time would be about 2 hours 40 minutes earlier than that provided for in the flight plan, with the arrival being at about 86 hours 14 minutes ground elapsed time. The 2 hour 40 minute difference being accounted for in a speedier arrival time at the moon. The translunar injection burn being targeted to be just slightly longer than would have been the case in a normal launch. And the spacecraft getting to the moon in a total elapsed time 2 hours 40 minutes less, in effect making up the lost time from the late launch. In order to get the flight plan back in agreement with the ground elapsed time, the GET or ground elapsed clocks will simply be moved ahead 2 hours 40 minutes between now and the time spacecraft arrives at the moon, so that by the time Apollo 17 is inserted into lunar orbit, the GET will once again agree with the flight plan GET, and of course the Central Standard Time of arrival will be the same as was originally planned by virtue of the speedier trip time. As a result of the late liftoff, it was not possible to program television coverage of the transposition and docking. This was because of a shift in the orbital ground track, moving the ground track away from the needed manned spaceflight network coverage for television. We simply didn't have an adequate ground station to receive the television signal from the spacecraft. There has been one recurring problem that as yet is unexplained. That is in the displays and control system. The crew reported on several occasions that master alarm was occurring. The master alarm manifests itself in the form of a light that flashes in the command module. There are 3 of these lights, and also a tone that comes on. And the normal procedure is when the master alarm light comes on and the tone sounds, the crew then looks at another matrix of lights to determine precisely where the problem is. However, when looking at this matrix of lights, none of them were lighted, indicating that some spurious signal had ignited or lighted the master alarm light, and that there was in fact no problem in the systems. There is at this point no explanation for the problem. However, engineers here in the control center are looking into the past history of panel 2, which is the panel on which a number of switches are located, which have triggered this master alarm, to see if there is a history of panel 2 that would indicate a possibility of some momentary short in the caution and warning system, which could give a master alarm. The problem at this point is an annoyance, but does not appear to be a serious problem. All other spacecraft systems are performing normally, and the trajectory to the moon is almost precisely as planned at this point. We do not anticipate a change of shift press briefing. The white team will be coming back on at the regular Central Standard Time of 4 p.m. tomorrow. And in light of this rather short turnaround, we're going to forego the change of shift press briefing. At 5 hours 36 minutes, this is Apollo Control, Houston.
Bob, have the first hit of contamination on window 5. It's covering probably the central, well, let's say roughly a rounded square about 7 inches on a side with a very thin film that's catching the sunlight. And slightly iridescent, but also very finely granular. Very finely granular. You can just barely tell what it is.
Roger, understand.
Looks like very uniform in thickness right now. Bob, it's Jack. We got a UCPA dump scheduled, or is possible at 6 o'clock. There's nothing sacred about that time, is there?
Nothing at all. Whenever you're ready, just go ahead and dump.
Okay. Bob, one of the things that we miss in our training is a good geography lesson, particularly on Antarctica. I got the monocular out, and apparently the dark band that Ron mentioned, interface between the continental water, is that between the pack ice and the water, and you can, by very subtle changes in the apparent smoothness of the ground, probably make out where the actual continent begins and the pack ice ends. There are a few exposed ranges. I guess it's midsummer down there now, and you can make out the snow-free areas scattered at least in the northern portion of the continent.
Raj, did you get any pictures of that, Jack?
Oh, yeah, we got some pictures earlier. I'm going to get another one here in a minute. I'll tell you, if there ever was a fragile appearing piece of blue in space, it's the Earth right now.
Roger.
And we got a master alarm.
Okay, we copy that.
And there's one in the LEV.
Okay, good data point.
And there are no caution lights.
It came right at accumulator cycle along with the high O2 flow again.
Yeah, I just checked the time, and I think you're right on that one. Well, we gave you your LEV data point.
Yes, sir.
The problem with looking at the Earth, particularly Antarctica, is it's too bright.
Understand.
And so I'm using my sunglasses through the monocular, which is not the best viewing platform. I think I can see some of the areas of the dry valley, but again, I'm not too sure of my geography, Bob. There are clouds over the continent, I believe, but of course they're just as white as the snow, and you only see differences in texture brought out by probably varying photometric return because of fairly low sun angles down there.
Roger.
But you can see patterns of what I believe is pack ice leading off from that sharp interface that was talked about earlier. And those patterns seem to merge directly with the patterns of the clouds, as if the, at least near the continent, the oceanic currents are controlling the air currents up to a point, along with the movement of the pack ice.
Roger.
Now, I'm distinguishing the pack ice from clouds mainly by the angularity of the patterns within them. There is no good, clear color or albedo distinction, so I couldn't be looking entirely at clouds, but I suspect there are some pack ice patterns too. I'm not keeping you awake, am I, Bob?
No, sir, just keep talking. We're listening, and I'm sure not much of the world is listening, but this will all be recorded. You can read it all when you get back and think it through, tie it up with the pictures, and I'm sure there's going to be people interested in this. And we're interested in ourselves. Just keep talking.
All I want to do is read what I say.
Right. If I had a little more geology training, I'd be asking you some better questions. Right now, I can't think of anything to ask you.
Well, I can't. I really wish I knew that geography. I don't know. I wish I'd thought of bringing a good map of Antarctica. Could somebody do a little researching for me and see if they could tell me if we're have a little American view, say, on the eastern edge of the continent?
Right. We'll see if we can get some Antarctica geographers around.
Yeah, I'd like to, and also whether or not they think the Dry Valley area is visible to us. Let's see, there's some of the people over there in Bill Benny's group, I think, have a little Antarctic experience, or used to, and they might be able to help you out.
Okay, we'll see what we can track down on it.
Don't use up a lot of people's time on it, but...
Right, it's getting pretty empty around here. It's 5 in the morning, so...
Okay, there is a good, strong northern hemisphere cyclone up near India, and I think Gene mentioned that. It, I think, was one I saw in some of the forecast sheets as a dissipating hurricane or typhoon. I'm not sure which it is there. I guess it's a typhoon. And I see something here that I noticed in Earth orbit, Bob, that as you approach the terminator, and now I'm looking at the eastern terminator. Gotta keep all my directions straight here. Yeah, eastern terminator. The clouds, those associated with the cyclone over India, and one that appears to be due south of there, maybe 30 degrees of latitude, have a gray appearance. Instead of the brilliant white of other clouds, as you approach the terminator, those, at least the high-level clouds, are gray. Now, when we were going over them in orbit, the lower-level clouds were still white, and I think I can see a hint of that right now. That the sun gives strong white reflections off of the buildups in the low-level clouds, whereas the high-level and relatively layered cirrus and maybe some of the intermediate-level stratus tend to look gray because of the grazing sun, I suspect.
Roger. You mentioned something in Earth orbit that kind of intrigued me. You mentioned seeing the rainbow, and we were trying to figure out how you saw a rainbow up there, and you were in orbit already at that time. Do you remember that?
Well, we were speaking of the appearance of the sunrise.
Okay,
Having a banded color appearance that varied as you approach sunrise. I can't remember what we did. I think we put some of that on tape. We were probably LOS at the time. But the banded character of the sunrise in the atmosphere was very, very marked. Was a gray-blue upper layer that merged or graded into a brilliant blue intermediate zone that was just above the cloud levels. And within the clouds, you've got a orange to yellow band, getting more yellow as the sun rose, that was broken by the dark patterns of the buildups.
Roger, good show.
Well, the interesting thing was the continual glow on the horizon we had even at night on the dark side path, and that glow was in the atmosphere because I could see stars rise over the horizon in it and then pass on through it.
As we were talking, the air glow, I guess, is a phenomenon most of the guys have seen before. It's kind of interesting, I guess.
Yeah, that's right. It's I guess standard air glow, but it is very striking that it's a continuous thing, even in the dark
Roger.
path. I think I just see the eastern tip of South America now.
Roger, you're starting to back up now, coming the other way, so you're still over Africa according to our chart here, but you're backing up towards the South America.
Yeah, I can see the part of South America that Wegener thought fitted into the bend in Africa some many decades ago, and started people thinking about moving continents around on the crust.
Roger. Jack, how'd the PGA doffing go? Are you all out of your PGAs now?
That's in work. We're taking it slow and easy up here, Bob.
Roger, understand. I'll just be curious to see if they all fit in that bag.
I think you'll find that Ronald Evans will also be curious about that. He's already made comments.
Roger.
This is Apollo Control at 6 hours, as Jack Schmidt gives the description of the Earth. Apollo 17 is 22,868 nautical miles from Earth, velocity 12,520 feet per second.
Certainly do have a very clear, intuitive impression, although the evidence is hard to pull together, that any frontal systems that move off the Antarctic continent do not take on any well-defined character until they get into the moist regions of the